Hi, my name is Simon, and here at Weidmüller, I have the role as a business development manager for single-pair Ethernet technology.
Hi, I'm Thomas. I'm product manager at Rosenberger, where I'm responsible for our single-pair Ethernet product portfolio for industrial applications. And together, we represent 2/3 of the board of the single-pair Ethernet System Alliance.
And in today's AVNET webinar, Thomas and I will introduce you into the use cases and the market potential of single-pair Ethernet in the industry. So let's take a look what we've prepared for you today.
After a quick introduction, we want to highlight a little bit single-pair Ethernet for digital communication, followed by a chapter from my colleague Thomas Keller on SPE infrastructure and connectivity, and we're going to give you some updates on SPE use cases, followed by a quick summary. But I would like to start this presentation with some help and great words from a great mind. Victor Hugo, French novelist and poet, and he said once, "There is nothing more powerful than a good idea whose time has come." And we all believe that single-pair Ethernet is a powerful and good idea to transition into a digital world, and the time has come now to implement these technologies. And I will try to explain you why with the help of an old pair of shoes. Now don't be surprised, we talk about product diversity over the course of time. So what you see here is the product variety, and this is the product volume per variant. And when we go back 175 years ago, basically 1850, that was the year when Weidmüller was founded, by the way, if you wanted to have a pair of shoe, what did you do? Well, you went to the shoemaker, he took exact measures of your feet, you choose the leather, you choose the color, you choose the shape, and everything was individualized according to your need. Then the shoemaker made the shoe, and it was an expensive and long-lasting task. Later on, as population was growing, there was the big demand for shoes. Mankind learned to split several tasks of the shoemaking process into different tasks. So one was making the leather, another one was making the sole, another one was making whatever. And so that brought up the product volume per variant slightly, but still going into the 1950s or 60s, when the era of the mass production began, that was the time where you had huge factories with people sitting there doing step-by-step mass production so that the product volume per variant was increased and the price was decreased. So that's basically how product diversity over the course of time works with an example of shoes. But we're now entering into an age where individualization, globalization, personalization and regionalization of products are very important for the customers. And taking this example, the pair of shoes, you see here, you can choose and go on a website and choose your own design for the shoe. You can use your own schemes and whatever you like. So you just decide what you want to have, and somebody on this planet is producing that in accordance to a requirement in a very short time at a reasonable price. So how do you do this? Well, the biggest important thing is that you need data. Data to transfer from the customer need into your production facility in order to operate your processes as efficiently as possible, and a seamless network is crucial for that. And when we talk about data, we believe that data creates value add for operations. So we need to ask the question, how does data really optimizes my machine? How does data helps me to save costs? And how can I use data to build up complete new business models, for example, like making these individualized shoes? So data needs to be collected and transported easy and efficiently, and data is the value add for the digital age and to the transition into that. To build that up, we need to have an automation portfolio that is generated based on existing modular hardware platforms using existing standards. It should allow us to have an engineering landscape where we can use visualization and software tools in order to build up a digital IIoT, preventing or providing intelligent communication from the sensor directly into the cloud. And that helps us for machine learning and many other stuff. So But when we talk about data, there is one data protocol which is basically a global data, standard, and that is Ethernet, of course. What you can see here is the development of industrial communication over time, and this is made from the famous HMS study. So you see here in gray, industrial Ethernet back in 2015 had 1/3 of the share of the field buses, followed by 2/3 from field buses. And in only 8 years, it has completely transitioned so that we now have 2/3, nearly 70% on all communications in the industry are Ethernet based, and only 1/3 is left for field bus communication. As you see the split of the different protocols here, we see a big growth for Ethernet-based communication in the industry. And that's clear because Ethernet allows us to move from a distributed hardware-defined network architecture, where we had area-specific hardware architectures, CAN, ASI, RS484, Modbus, RTU, and whatever it is. You had multiple application-specific buses which you need to bring together at the end of the day. You had a lot of distributed gateways and, of course, a complete complex cabling infrastructure. And that all changed now from distributed hardware to more likely centralized software defined. Means that the OT and the IT are getting together. And that allows us to have different zones in the enterprises that are connected directly to the cloud. That allows us IP-based area-wide IP networks, and it's this cost-effective single-pair Ethernet cabling is a key enabling technology. But what is that single-pair Ethernet? And I'll try to make that aware, or make you guys aware about that with the help of a little video.
Single-pair Ethernet, infrastructure for the world of tomorrow. Industry is in flux. Digital connectivity and modularity are penetrating industrial technology and enabling highly flexible production. But often in the final layers of automation, connectivity still comes up against structural barriers. How can these barriers be overcome? With single-pair Ethernet, or SPE for short, the next generation of Ethernet technology, which for decades has been one of the main arteries of industrial digitalization. SPE takes Ethernet connections, which traditionally have either 2 or 4 pairs of cables, and narrows them down to just 1 pair. This saves space and enables comprehensive, standardized communication between many devices via the Ethernet protocol. That way, SPE can rely on existing structures and lengthens the reach between active components to 1,000 meters. The support of power over data line, time-sensitive networking, and OPC unified architecture result in maximum flexibility and availability, protecting application security even in time-critical scenarios. The bottom line, single-pair Ethernet is the key technology for Industry 4.0 and the industrial Internet of Things. The old hierarchy of devices is being replaced by a multitude of smart devices which are connected according to consistent standards from the sensor all the way up to the cloud. That's how SPE enables flexible production processes and innovative solutions for every type of application. Single-pair Ethernet, infrastructure for the world of tomorrow.
So as you can see, Ethernet provides a lot of benefits because it's standard. You have here the 7 layers of the OSI model, and the industrial protocols, the TCP/IP, the UDP, the Ethernet, all of that is already defined. And when we take a look at, as an example, Profinet today, we have the installation in RJ45, we have integrated power, which is PoE, and we have the physical layer according to IEEE 802.3. Now this physical layer can be changed easily by using single-pair Ethernet, where we have standards like 10BASE-T1L, 10BASE-T1S, 100BASE-T. We have the power supply with the USB1 or power over data line, and we have hybrid and connectivity solutions to go from an 8-wire Ethernet to a single-pair Ethernet. So new Ethernet transceivers who are working are maintaining basically the network layer 5 to 7. So that's all the same. So if you have developed anything for Ethernet that is based on 8 or 4 wires, you could easily implement that also in a 2-wire environment. And that brings us multiple bandwidth under the IEEE 802.3 standard, which provides the 10 megabit S, which is a multi-drop bus, or the 10BASE-T1L, which is 1 kilometer with 10 megabit. It provides 100 base. Currently, IEEE is working on a standard for 100 megabit at up to 500 meters, and many more. So it's all Ethernet. And single pair Ethernet reduces basically the system cost, the system weight, and of course, the complexity of the wiring. And to have a better understanding where that is coming from, where the origin of single pair Ethernet, I would hand over to my colleague Thomas Keller. He is an expert in automotive Ethernet. Thomas, tell these people here what single pair Ethernet in automotive is all about.
So far, you got an impression of the expanding rate of data and with that, the massive growth rate of an Ethernet-based communication for the industry. And that is only the beginning. But now to the roots of single pair Ethernet. Single pair Ethernet has its origin in the automotive industry. Because of the fast-growing rate of sensors and actors in a car, a change of the data communication was necessary. But before we talk about the change, let's have a look onto the upcoming megatrends from the automotive sector. Autonomous driving. To guarantee a good performance and a safety drive, you need many different sensors in your car. Connectivity, an example. For infotainment, a seamless connectivity with high data rates is important. Electrification, another megatrend, is the electric drive, just to mention that one. And in the future, we'll have the shared services. With all the sensorics in a modern car and the available data, you can create learning algorithm. Your car will become more and more individually according to your own personality. The key for that future are data and the data communication. To handle all the information, all the data, the architecture of a data transmission in a car must be changed. A few years ago, the cars had a traditional architecture, different bus systems with different speeds. The architecture is historically grown with the features of a car. Almost each new technological achievement came with its own communication protocol. A modern car has a domain architecture. This architecture is split into different domains like infotainment or driver assistance. It is a logical structure for high-speed requirements. The future car will have a zone architecture. All the sensors can communicate with each other and high-speed single pair Ethernet will be necessary. And that's where we are today, the new communication standard, single pair Ethernet. But a communication standard is not the only thing you need. You need also standardized connectors. In the automotive industry, you have for single pair Ethernet mainly two different interfaces. One for short distances, for unshielded cables, and one for high-speed applications, 360-degree shielded cables and connectors. For example, the MTD, the modular twisted pair data, and the HMTD, the high-speed modular twisted pair data. Both are open interface standards and also usable for other industrial applications. Now, really short, a few key arguments for single pair Ethernet in the automotive area. Single pair Ethernet has its roots in the automotive industry because of the large data rates, the small installation space, and the possibility of power transmission over one pair cable, called Power over Data Line or POODLE. It is a universal communication architecture with a single connector family and will replace the existing field bus systems. It is a two-wire connector systems which reduce the installation space and the weight, which is really important in the automotive area. And because of the simplicity for the wiring, you will have a reduction of the overall manufacturing costs. So that was a short insight into the automotive industry. But how is it in other industrial areas? Let's start with the standards. As I mentioned before, many companies from non-automotive industries are using the automotive standards. But there exists also an industrial standard for the connectivity solutions, the IEC 63171. The IEC 63171 describes the general requirements for single pair Ethernet connectors. For example, the transmission characteristics, electrical and mechanical characteristics, and test requirements. The IC 63171 has substandards for different connector interfaces and for different applications. Let's have a closer look to those substandards. Here an overview. The -1 is a LC-style connector with a focus for building application. The -2 is a rectangular style for the building and the industrial field. The -3 is cancelled. The -4 is a MMC style with a focus on building and data center. The -5 is a M8, M12 standard for industrial applications. The special on the -5 is that it has the same interface as the -2, which has the benefit of the interoperability, for example, for service inspections. The -6 has many different styles with the focus industrial applications. And the -7 is for M12 hybrid connectors, also for industrial use, especially where you need a higher power transmission to your device. So, Simon, show us a few use cases.
Thank you, Thomas. So single pair Ethernet provided a lot of benefits in the automotive industry. Everything good? Well, not yet. Because even today we are facing several challenges in the automation industry today, and we are facing challenges in the automation industry in the future. Just to name a few, we have, of course, the complexity of the communication that we have today. We already said that this is different protocols. We need expert knowledge. We have different cables and connectivities, and we have really difficulties in changing existing processes when we change something in the process. And we have specific hardware. So we have hardware-defined communication. If you have a specific hardware, you need a specific guy who knows how to program that hardware. We have less event-triggered communication and energy efficiency. So energy management in today's communication architecture is not really a big topic, but it should become a bigger topic for sustainability. And we have a lot of, let's say, localized information. They are at the machine, but they're not part of the network. And last but not least, we have no standardized safety or security, which could be easily implemented with single pair Ethernet using Ethernet technologies on that. So these are the challenges that automation installers are facing today, but we also have problems or challenges for the future. There is one to say a demographic change. So we have a lack of competent, skilled workers for all these 30, 40, 50-year-old bus systems. All of the students that are coming out of the universities today, they know how to program an Ethernet switch, but they don't know how to do a BACnet or Modbus implementation. They first need to learn it. And we have some issues regarding governmental reporting. One is the CSRD, which is the Corporate Sustainable Report Directive from the European Union. This directive forces companies to give adequate data about their sustainability efforts. And how do you generate these reports? Well, first you need to have those data. So single pair Ethernet, or a transparent flow of data about your sustainability goals, your energy consumption, your carbon dioxide footprint, and many more, will help to establish a single pair Ethernet network. And very actual topic, cybersecurity, the so-called IEC 62443. There is this Cybersecurity Resilience Act in the European community right now, forcing companies to harden their communication architectures to prevent cybersecurity issues, let's call it that way. There's a bad world outside. They all want to know the details of your production processes. So you have to implement cybersecurity processes. And there are still several communication networks and architecture who do not prevent anything regarding cybersecurity. But Ethernet does. And so Ethernet is the protocol of choice, and single pair Ethernet could help us to bring those Ethernet-based infrastructure down to the last mile. Now, when we talk about the last mile, I think this is a good example. Here we see SPE migrates into the control cabinet. This is our well-known automation pyramid. And as you can see here, on the upper levels, we have standard Ethernet. Here on the operation level, on the control level, we have industrial Ethernet, Profinet, EtherCAT, and all of these different Ethernet-based systems. But still here on the bottom part, we still are missing Ethernet communication. And here we have I/O link, we have 4 to 50 milliamp, we have digital I/O and analog I/O. So the idea is, from a system architecture, to have all of this as the focus of the industry transverted into a single pair based Ethernet, providing the possibility of integrating existing field buses via gateways into the Ethernet infrastructure, but also integrate a seamless sensor communication based on Ethernet into the overall application or into the overall automation permit from the companies. And that will provide a lot of benefits. And so when we take a look at some of the benefits here, for example, the use case mechanical engineering means for a machine. So you have modular machine engineering. All of these new machines are becoming more and more modular. So we have the machine-to-machine communication, the machine-to-the operation network communication. We have the machine-to-the-sensor communication, and all of that needs to be brought together in one seamless network, and single pair Ethernet helps to introduce or include sensors, the monitoring, the calibration, the communication, in order to have a uniform communication infrastructure with cost reduction potential. And of course, that's also saving a lot of space, as single pair Ethernet is only using small connectivity infrastructures. So machine builders will benefit from the fact that single pair Ethernet provides all of these benefits of a seamless network integration. Another use case that we see is, for example, here on a robot. On a robot, you have here the application of a gripper. So all of these parts here are filled up with sensors and actuators. Position sensors, force sensors, feedback sensors, high-speed cameras. And if we get more and more into a robotic age where we have collaborative robots, means that people and robots are working together, you need to have very good sensing of the robot that provides a lot of data. And so single pair Ethernet can help to realize application detection inside a robot using high-speed standardized data communication on the Ethernet basis in order to prevent any mistakes. And due to the size of single pair Ethernet and the small size of the cables, you also have a good possibility for all of these bending radiuses inside the robot, regardless whether it's a big robot or a small robot. Another example here is, for example, the production workspace. So on a production workspace, you have barcode scanner, you have vision sensors, you have user terminals or detection sensors. That means you could use single pair Ethernet for the sensor-to-sensor communication. Multi-drop 10BASE-T1S is an outstanding protocol to have various different sensors on a production workplace. You can use the sensor to cloud so that you can exactly monitor what the operator is doing on the workspace. And of course, you have the possibilities for sensors for remote diagnostics in order to, well, do the logistics, the stocking, and all of the other stuff. So there are several benefits for single pair Ethernet. And last but not least, one more use case, which is also very important for the building automation market. For example, here at the energy management and security and access control, where you can use Ethernet-based sensor systems, which are part of the overall infrastructure of a network anyway. You can realize access control, RFID cameras, or also for the sustainability and the carbon dioxide footprint of the overall building, you could use sensors for flow of the temperature, carbon dioxide to have window shades realized or starting. So this is really a great possibility to have a seamless network for single pair Ethernet inside a building. So that were only just 4 use cases out of more, and this is why we believe that single pair Ethernet as technology is really, we call it unstoppable. Just like that wave that it's coming towards you. You can see the shores from behind. You see that it's coming, and it's going to hit the market anyway. So let's get prepared for that. We believe that single pair Ethernet has a market potential of 50 million nodes by the year 2025. And we, here at Weidmuller, we're not the only ones who believe in the power of single pair Ethernet. So Thomas, the Single Pair Ethernet System Alliance also provides lots of benefit. So can you tell us a little bit more about that?
Before we come to the end, I will tell you something about the Single Pair Ethernet System Alliance. The Single Pair Ethernet System Alliance is an open association of leading technology companies and scientific organizations from different industries and fields of applications. We have currently more than 70 partner companies in our association, and we all have the common goal to support the exciting technology. To do so, we cooperate in different working groups where we share our knowledge, prepare presentations, writing white papers, social media campaigns, and so on. For example, we are working together with the Centrum Industrial IT, or short CIAT, on a new demonstrator for a manufacturing plant, where we implement the existing Single Pair Ethernet products from our members. With our association, we also joining different fairs and events where we focusing on the technology marketing and on live demonstrations. So last year we had our own booth at the SPS and the Hanover Trade Fair. And because of the great response, we will join these fairs this year again. Here a short video. To get a deeper look into our activities, visit us on our website, singlepairethernet.com. You'll find there a lot of video content, explanation of live Single Pair Ethernet applications, interviews and member statements, roundtable discussions and expert talks, white papers, and much more. Before we start with the questioning, now a short summary. Single Pair Ethernet offers the opportunity to implement automation end-to-end all the way to the sensor. It offers the possibility to implement a standardized Ethernet network and at the same time integrates existing field bus infrastructures. Numerous use cases can be realized with Single Pair Ethernet and offer advantages in planning, installation and maintenance to save costs. The challenge is to adapt the IEEE standard made for the automotive industry to the need of the industry. Many companies and user organizations have set out to build an ecosystem for the Single Pair Ethernet technology. So that's it. Let's come to your questions.